Launched by NASA in 1977, Voyager 2 stands as one of humanity's most extraordinary accomplishments in space exploration. Almost half a century later, this incredible spacecraft continues to send back invaluable data, traveling deeper into the cosmos than any mission before it. Even after decades of its journey, Voyager 2 remains an active beacon of scientific discovery, constantly enriching our understanding of the universe. What has Voyager 2 uncovered on its incredible odyssey? The answer is a testament to humanity's relentless pursuit of knowledge, a journey that has taken us beyond the planets, past the sun's influence, and into the heart of interstellar space. As Voyager 2 presses on, crossing frontiers never before seen, it offers humanity a window into the most remote corners of the universe. And this is just the beginning. Hold tight, because we are about to embark on a thrilling journey to the edge of the solar system, a point where our sun's influence fades and the vastness of deep space begins. The moment Voyager 2 crossed this threshold marked an achievement that would change our understanding of the cosmos forever. Crossing the heliopause, a monumental milestone. Let's begin with a landmark event in Voyager 2's mission, the crossing of the heliopause, the boundary that separates the solar system from interstellar space. To understand its significance, imagine a giant bubble created by the sun. This bubble is known as the heliosphere, and it's filled with charged particles from the sun, called the solar wind. This solar wind pushes outward, filling the space around our solar system with a continuous flow of energy and particles. As Voyager 2 journeyed outward, it traveled through this bubble of the sun's influence. But at some point, the solar wind can no longer push back the matter from interstellar space, the matter that exists between the stars. This boundary, the heliopause, marks the edge of the sun's protective shield, where the solar wind finally gives way to the particles that come from other stars. In November 2018, Voyager 2 became the second human-made object in history to cross this boundary, following its twin, Voyager 1, which crossed the heliopause 6 years earlier in 2012. But Voyager 2's journey was unique. It made its crossing with one crucial difference: its plasma detector was still operational. This allowed it to directly measure the density and temperature of plasma, gas made of charged particles, both inside and outside the heliosphere, providing insights into the very transition from solar wind to interstellar space. When Voyager 2 crossed into this unknown realm, it recorded a sudden drop in the solar wind's particle density, along with a rise in particles from the interstellar medium, the gas and dust that permeate the space between stars. This was conclusive evidence that Voyager 2 had truly crossed the heliopause and left the sun's direct influence behind. It was an extraordinary moment in space exploration, marking the first time we had a spacecraft standing on the threshold between our solar system and the stars beyond. Unveiling the unknown, discoveries beyond the solar system. Voyager 2's passage beyond the heliopause revealed many new and unexpected findings that reshaped our understanding of the universe. Plasma density. One of the most significant discoveries occurred when Voyager 2 measured the plasma density in interstellar space. The spacecraft's instruments found that the plasma in this region was denser than the solar wind inside the heliosphere. This finding provided important new information about the characteristics of the interstellar medium, and its interaction with the heliosphere. Unlike Voyager 1, which had its plasma detector switched off by the time it crossed the heliopause, Voyager 2 was able to make direct measurements. These observations were a major leap in our understanding of the space beyond our solar system. Cosmic rays and the shield of the heliosphere. Another pivotal discovery came when Voyager 2 measured the cosmic rays, high-energy particles that are generated by phenomena like supernovae and other cataclysmic events in the galaxy. Within the protective bubble of the heliosphere, the solar wind shields us from many of these cosmic rays. However, when Voyager 2 crossed into interstellar space, it recorded a sharp increase in the intensity of these cosmic rays. This confirmed the Sun's heliosphere is indeed a protective barrier, shielding the planets, including Earth, from the full force of the galactic radiation. The spacecraft's observations also highlighted just how essential this shield is for life on Earth. Without the heliosphere, we would be exposed to far greater levels of radiation from deep space. Magnetic fields at the edge of the solar system. Voyager 2 also made a fascinating discovery related to magnetic fields. It found that the magnetic field at the edge of the solar system, where the heliosphere ends, closely resembled the Sun's own magnetic field. But even more intriguing, the spacecraft observed that the interstellar magnetic field, the field that permeates the space between the stars, was interacting with the Sun's field in unexpected ways. This finding raised new questions about the boundary between the solar wind and interstellar space and has provided a fresh perspective on how stars influence their surrounding environments. A dynamic boundary. The heliopore's ever-changing nature. The data gathered by Voyager 2 also revealed a fascinating aspect of the heliopause. It's dynamic, not static. The boundary between the heliosphere and interstellar space is not a fixed, unchanging line. Instead, it expands and contracts, shifting in response to the activity of the Sun. This means that the heliosphere, our Sun's vast protective bubble, is continually reshaped by solar flares, sunspots, and other forms of solar activity. This new insight challenges old assumptions about how the Sun's influence interacts with the broader interstellar environment. As Voyager 2 ventured into the cold, dense environment of interstellar space, it also found that the conditions beyond the heliosphere were radically different from those within it. Whereas the solar wind is made of hot, low-density plasma, the interstellar medium is far cooler and denser, made up of particles from stars and cosmic events far outside our solar system. These observations offered humanity a rare opportunity to study the conditions of deep space, an environment never before studied in such detail. What does Voyager 2's journey mean for us? Voyager 2's findings have profound implications for our understanding of the Sun, the solar system, and even the broader galaxy. By exploring the boundary of the solar system, Voyager 2 has allowed us to see the Sun's influence in a completely new light. This knowledge will prove crucial for future space missions, particularly those that venture beyond the reach of the solar wind, like the upcoming interstellar probe. But Voyager 2's journey also touches on a more fundamental, even philosophical question: what is our place in the universe? By mapping the outer reaches of the solar system, and entering interstellar space, Voyager 2 has shown us just how vast the cosmos truly is. The heliosphere, once thought to be a fixed boundary, is in fact a dynamic region, shaped by cosmic forces and constantly interacting with the space beyond. This reshapes our understanding of not just the solar system, but also our position in the grand cosmic web. Voyager 1 versus Voyager 2, a tale of two spacecraft. Though Voyager 1 and Voyager 2 were launched just a few weeks apart, their missions have unfolded in strikingly different ways. Both spacecraft were designed to explore the outer planets, but their paths diverged after they completed their planetary flybys. Voyager 1 took a faster trajectory, reaching Jupiter and Saturn ahead of Voyager 2. The spacecraft made history with its discoveries of Jupiter's Great Red Spot, the first evidence of volcanic activity on Io, one of Jupiter's moons, and stunning images of Saturn's rings and its moon Titan. After these encounters, Voyager 1 was sent out of the solar system's plane to explore the interstellar medium. Voyager 2, however, took a longer path and visited not only Jupiter and Saturn, but also Uranus and Neptune, making it the first and only spacecraft to visit these ice giants up close. Voyager 2 discovered Uranus's unusual magnetic field, observed Neptune's astonishing blue atmosphere, and even recorded the fastest winds in the solar system, winds so powerful that they exceed 2,000 kilometers per hour. Despite following separate paths, the two spacecraft's complementary missions have provided a wealth of data that deepens our understanding of the solar system, and the space beyond. Together, Voyager 1 and Voyager 2 have opened the door to interstellar exploration, and provided the foundation for the next generation of missions.